Hello and welcome. In this video, we will look at the IEC 60870 server component, available with the 2022.2 release of Typhoon Hill Control Center. The International Electrotechnical Commission IEC 60870 standards define systems, such as SCADA systems, which utilize data transmission for monitoring and controlling geographically widespread processes. Systems such as this are mostly used for telecontrol in electrical engineering, power system, and distribution automation. IEC 60870 is an Ethernet-based, TCP/IP communication protocol. The IEC 60870 server component, now present in the Typhoon Hill toolchain, emulates a real IEC 60870 server in the Hill device and complies with the IEC 60870-5-104 standard. It is available as a part of the communication toolbox. The IEC 60870 server component in version 2022.2 of Typhoon Hill Control Center only supports one server per Hill device. However, an increase in the number of servers per Hill device is planned for subsequent releases. To show how to set up the communication layer and how it works, we will use an IEEE 4-node model with an implemented IEC 60870 server. To establish a connection to the server in the model, all devices that communicate using IEC 60870 protocol must be connected to the same network and on the same subnet. This can be established either by using an Ethernet switch or by connecting a Hill device directly to a PC on that network using an Ethernet cable. It is important to note that the protocol component must be used with a supported Hill 4 and 6 series device. It does not work with virtual Hill. Now, let's open the IEC 60870 server component. In the bottom left corner, we can configure network properties such as the IP address, port, and netmask. In the Input Messages tab, we can add new and edit existing input messages. Input messages are sent from server to client. In this model, the server will provide signals such as voltages, active, reactive, and apparent power to the client. Creating a new input message creates a new input port on the component. For each message, we can set numerous parameters, the first one being the name of the message. The communication in this protocol is realized through blocks of data known as Application Service Data Units, or ASDUs. Each ASDU is defined by its common address. Each of these ASDUs can contain a finite number of information objects, which are defined by their info object addresses. After setting the message name, we can set these two parameters. After that, we can select the message type. We can choose to include or exclude a timestamp of a message by using the timestamp checkbox. We can also select the cause of transmission, such as periodic or spontaneous, using the appropriate column. Lastly, we can assign different ASDUs to a station or to different groups, by using the qualifier column. The process of setting up output messages is practically the same as with input messages. Output messages are sent from client to server. Here, we will be using the client to set the state of the contactor in the model. Now, let's compile the model and load it onto SCADA. To stimulate this demo, an external client called IEC 60870-5-101-104 test tool is used. This program is an implementation of the IEC 60870 client application. After starting the simulation in Hill SCADA, we establish a connection to the external client by choosing the appropriate IP and port in the client, which must be the same as the ones defined in the server component. By performing system interrogation, the client receives the defined information. Here, those are voltage values and values of active, reactive, and apparent power measured in Node 4. By choosing the Monitoring Reverse option in the Commands tab, we can send an output message from the client to the server. First, we need to define the appropriate common and info object addresses of the previously defined output message. Since we are sending a binary value, we can choose off, meaning a binary value of 0, or on, which is equivalent to a binary value of 1. By sending on, we change T state of our contactor to closed, indicated by noticeable current and active power values in Hill SCADA. In this tutorial we showed how, From the 2022.2 Typhoon Hill software release, you can use the IEC 60870 communication protocol in your Hill simulations. Thank you for watching.